Welcome friends, we are now heading towards the lecture 12 on module 1, where we are focusing on safety assurance and assessment in the course of health, safety and environmental management in offshore and petroleum engineering under the auspices of NPTEL IIT Madras. I hope you have followed the 11 lectures earlier. There are 2 tutorials which you must have submitted. The third one is also on the pipeline. Any doubts you have, please post it to NPTEL discussion site so that your questions will be answered accordingly. Let us enjoy lecture 12 now, which will focus on failure mode effect analysis. Failure mode effect analysis is one of the tools which is considered as an alternate method of hazard identification. This considers all possible outcomes from all failure modes or deviations. We already know, dear friends, what are the design intents and deviations in a given problem identified for either a machinery or a process situation. FMEA method is suitable to complex mechanical systems and electrical systems. It can be applied at different levels of complexity of a given problem. Essentially, this is one of the quantitative risk analysis or hazard identification tool which is applied to mechanical and electrical systems, whereas in the earlier couple of lectures we discussed about the hazard method which can be applied to the process management systems. FMEA is therefore a systematically identifiable tool to identify the consequences of a component level failure. We all know that mechanical system is a combination of different subsystems which we call as components. Now, the overall system failure will occur or will be generally directed by the failure of different component levels. So, it is important for us to do a micro level analysis for a given complex system, because it is very difficult to analyze the complex system as a whole. Therefore, we divide the complex system into component levels, and FMEA is a very interesting tool which identifies the consequences of component level failure. It determines significance of each failure mode with regards to the system's overall performance. On the other hand, if the system comprises of different components, we identify the failure of different components in a specific order or hierarchical manner, where the consequences of failure of these systems or subsystems or components will affect the overall performance of the entire mechanical system. So, this study should be able to give you the consequences in hierarchy of failure modes or different failure modes of component levels in a given complex mechanical or electrical systems. This method is primarily used to study material and equipment failure. As the name of FMEA suggests, each failure mode within the system is traced by this method. Effect of the failure of these items or components on the overall performance of the global system is then subsequently examined. So, the entire outcome of the study is the significance of failure of the components on the overall system, whereas the study focuses on the failure of the components part by part, which leads to the successive overall failure of the entire complex system. Each of the failure mode is carried forward in a sequential manner to estimate its overall effect on the performance of the given mechanical system. Let us quickly see what are the steps involved in conducting an FMEA for a mechanical system. First, we have to define the system which needs to be evaluated. So, this kind of study cannot be applied if the conceptual design of the system is not available. Usually, for a successful FMEA, one needs to at least conduct a scaled model investigation of the system. Therefore, based on the experimental investigations, one can then arrive at the different failure modes categorically and systematically. Dear friends, please understand, hazard is a perceived level of failure for a given process system which is in anticipation, whereas FMEA is a prescribed level of failure analysis for a given system where the system should physically exist, not necessarily the prototype model of the system, but at least the scaled model of the system should be available to you. Therefore, FMEA studies are generally conducted to pre-analyze the failure mode of a given product before it is marketed or before it is even started production. So, first define the system which needs to be evaluated. Once the system is defined completely, then after understanding the mechanical process of the system, identify the functional relationship of different components present in the system and their performance requirements. Dear friends, you will be able to now recollect that these are the design intents. Every component of a given mechanical or electrical system is designed with a specific intent. Let us try to capture the design performance of every component at this specific stage, which is the second step in FMEA analysis. Once you do this, then establish the level of analysis, what kind of analysis you wish to do. Once you decide the level of analysis, which I will come to the next slide, identify different failure modes. You have got to anticipate the failure modes. It is very difficult, as we all understand, to anticipate the failure mode for a mechanical system if the working model of the system is not available. It is because of this reason I told you in the beginning that it is essential. First, we have got to make a scaled working model of the system for which we need to do an FMEA study. So, from the experimental investigations of a scaled model of the system, let us then subsequently identify different failure modes, their causes if the failure is materialized, then their consequences or what we call effects of this failure on the overall performance of the entire system. Most importantly, dear friends, please note, it is not only necessary that we should know what are the causes and effects. The most important feature of FMEA is the sequence of failure. Under the given set of components, which component fails first, which components follows the failure of the first component, and so on. So, this is the only study which gives you categorically the sequence of failure. As you saw in the hazard, they are not interlinked completely, whereas in FMEA, which is a quantitative method of risk analysis or hazard identification, it is essentially interesting that this method of analysis gives you, most importantly, or should enable you to identify the sequence of failure. So, dear friends, define the system, identify the relationship functionally between the components and the performance requirements. Therefore, it is a design intent here. Establish the level of analysis which you wish to perform, then identify different failure modes, their causes and their effects, and most importantly their sequence of failure in which we envisage their relative importance in a given overall assembly. Once this is done, then we are through with identifying the failure detection and subsequently the rectification methods or mechanisms. Then identify the design and operating provisions against such failures. So, it is a very interesting pack of risk analysis which tells you what are all the sequences of failure that are envisaged in a given model. Now, it is very clear that you have a question in your mind, how we can envisage a failure mode for a mechanical system if the mechanical system is not in operation. It is an interesting question. That is why I told you in the beginning, for performing FMEA, it is mandatory that you should have a working model, preferably the prototype model, but since these models are very expensive, people generally construct scaled models of these prototypes, and then based on the working mode failures, they identify the sequence of failure, and then if the failure are envisaged properly during experimental investigation, then you can identify any modification in the design and the operational provisions, so that these failure modes can be avoided or can be eliminated or mitigated completely, so that the product outcome after FMEA will be more or less a failure foolproof design. Then you try to summarize your action report and give a recommendation to the manufacturer that what recommendations you suggest as an FMEA team to modify the design or to modify the operational conditions of a given mechanical or electrical system. Therefore, the failure is minimized. Let us talk about slightly elaborate manner of definition of the given system. As the process may become complex, FMEA generally is performed in smaller steps. So, FMEA is generally performed at component level. Therefore, FMEA is one of the studies which addresses component level failure. It establishes the extent of the system to be studied. The whole system obviously cannot be studied at one shot. You divide them into segments and keep on understanding and identifying and then doing failure analysis of different segments or components of a given overall system. Most importantly, dear friends, it is necessary that we must link the interaction of different components and we must understand them beforehand. Then only one can easily find out the sequence of failure in a given system. Now, there is a question in mind, what do we understand by level of analysis? FMEA is generally performed on the functional structure of a given system. It is not on the physical components. Please understand, component level analysis means components while working. Therefore, we need to have a working, scaled or prototype model of a given mechanical system if you really wanted to perform an FMEA on a given system. So, FMEA does not focus on the physical components, but the functional structure of a given mechanical system. In the functional structure of a given system, failure modes are expressed as failure to perform a particular function. Now, ladies and gentlemen, you will be able to integrate this statement, specifically this particular statement, with that of an ASAP study, which is a qualitative risk analysis, where this is nothing but the deviation in a given system. So, the first part of FMEA spoke about design intent. The second part of FMEA is speaking about the deviation, which is addressed as level of analysis. Therefore, there is no principal difference between qualitative and quantitative risk methods of analysis. In qualitative, we speak about perceived failures, whereas in quantitative, we speak about identified failures. Now, when we talk about the level of analysis, it may be a primary function. Primary function are those for which subsystem is provided, or it can be a secondary function which is one of the consequence of the subsystem's presence. So, this is where the level of analysis means. The level of analysis can be applied to a primary function or a secondary function, which is a derived function of the presence of the subsystem, which is a primary function. When we talk about analysis of the failure modes, one should identify all possible failure modes in a given mechanical or electrical system. What are the possible failure modes which you can always identify in a given system? Following is a brief list of the possible failure modes. The system can have a premature operation. The system can result in failure to operate when required. For example, a valve. The valve should open or close at a specific temperature, pressure or flow of volume. If the valve does not close at a specific operational conditions, then it is identified as failure to operate when required. Sometimes there can be failure during intermittent operation, failure to cease the operation when required. For example, the valve should close but does not close. Loss of output or failure during operation may be sensors, alarms. Alarm should work when there is a demand. So, loss of output or failure of an alarm during operation, or it works but not satisfactorily, what we call degraded output. These are possible failure modes of a given mechanical or electrical systems for which the components leading to are responsible for such failures are identified in a method called FMEA. After identifying the various failure modes, then the likely cause, the reasons for the failure, and if at all they fail, what would be their consequences. Now, dear friends, you will know that FMEA is purely a risk analysis method because it also tells me the probability of failure modes. In addition to that, it also gives me the consequences or the effects of these failure modes, and we know that risk is generally the product of these two. So, FMEA is one of the quantitative risk method which analyzes risk in a given mechanical or electrical system with a focus to the subsystem or to the components in a given global system. It essentially focuses on the components concerned and the consequence of the failure on an overall performance of a given system. Please note that you shall have the consequence completely addressed only when you know the sequence of failure. In such cases, consideration is generally given to relative importance of the effects and the sequence they occur. So, importantly, you try to grade them in terms of which component will fail first, which component will fail next. Therefore, you grade the failure and that will give you the importance of the component in a given system. So, in an FMEA study, as an output, you can easily identify the most critical or the vital component of a given mechanical system. If you want to provide any safeguard to avoid or to prevent the consequences of failure of the component, then one can also talk about safeguards which you already provided in the design. If any, then should be also examined and see and check whether these safeguards are capable of mitigating or minimizing the effects of failure. Once you do the analysis, the most important part of the analysis is how will you document it, how will you report the results of the given analysis. Identify the most significant failure in terms of their effects on the overall system. Also identify whether the existing safeguards and detection devices are adequate enough to perceive these damages in advance. Most importantly, dear friends, try to identify the weakest possible link in the given system. Now, the question comes, what do you mean by weak link in a given system? Weak link will be the one that has got the highest rank of failure. Then one have a question, where are we ranking the failure? We already said that the components which are identified for the causes and consequences are also sequentially arranged in terms of their merit order. So, this merit order arrangement will tell me which is the most vital or the critical component which has the most serious consequence of failure on the overall system. Therefore, we are trying to rank the failure in a specific order, especially and preferably in a descending order. The highest component which has got the maximum consequence of failure will get the highest risk rank, as we also saw in Morgan's analysis. So, that would be the weakest link in a given mechanical system. So, identify the weak link in the given system, then do detailed analysis of the components of that system which is present in the weak link. Weak link may not essentially be only one component. It can be series of components for which we have got to do a detailed analysis, specially and particularly in detail. If so, then one may also redesign the entire weak link to reduce the probability of failure of these components in a given weak link. So, essentially and interestingly, dear friends, FMEA identifies the weakest possible links or components in a given system, enables you to redesign the system. Therefore, the probability of failure of the components in a given system are minimized. If the components of failure are minimized, the success of overall working of the system is always reached to its maximum probability. Now, one will interestingly like to know what would be the format of reporting an FMEA study. The format appears like this in a tabular column. You must identify the component, the perceived failure mode of the component in working, not the physical condition, the effects or the consequences of this failure on the overall performance of the given system. Please understand, dear friends, the failure effects is the consequence of failure of the component on the overall system. It is not the consequence of failure of the component alone in locally. So, FMEA connects the component failure to a system failure. It integrates from segments or parts to the whole. Ultimately, one can give also the respective comments related to whether these failure effects can be minimized, mitigated, or can be controlled by either redesigning the weakest link in a given system or by inducing more advanced features in the design, so that the component level failure can be easily prohibited or prevented in a given system. Therefore, the overall performance of a given mechanical system can be assured to the highest probability of success. FMEA is therefore a systematic tool for identifying the effects or consequences of a potential failure, methods to eliminate or reduce the chances of failure of an overall system, because you are able to understand clearly the failure of components of a given system. FMEA therefore generates a living document. Now, one can ask me a question, why FMEA is called a living document? It is called as a living document because FMEA is one of the QRA methods which is trying to identify the failure when the model is working. That is why we call living document, which can be used to anticipate the failure modes, and therefore one can either redesign or try to prevent this failure from occurrence to an highest possible extent. Having understood some brief idea about how FMEA is going to be done, how they will be reported, what are the merits of FMEA, what are the intrinsic comments an FMEA can give to a designer, so that the overall success probability of a mechanical system can be achieved. Having said this, now the fundamental question in any designer's mind is when to use an FMEA. Is it mandatory or is it optional? FMEA, if it is used before the design, it will be very useful because your scaled model working can be easily corrected by some design features, so that the end development of the product can be more or less successful. So, when used before the design, it is always considered to be extremely useful. It should be used before the final design of any product is released. The objective of FMEA, please understand friends, is on failure prevention and not on detection. Failure detection is only an observation. You need not have to have your working model to detect a failure. What we are understanding here from FMEA is how to prevent the failure if the failure is envisaged to occur or definite to occur in a given mechanical or electrical system. So, failure prevention is the motive and failure detection is not the motive. FMEA is considered as a standard procedure which is used in development of new products. Therefore, it is very useful for design and development of new products before they are launched in a commercial market. There are two types of FMEA which the literature governs and decides in a given system. One is what is called design FMEA, other is called process FMEA. Design FMEA examines the function of a component, subsystem or a given main system. It identifies the potential failures based on improper material choice, inappropriate specification, etc. Whereas the process FMEA examines the process used to make a component, identifies the potential failures in terms of operator assembling parts incorrectly, etc. So, one talks about workmanship, one talks about the design. Put together is the development of a good product. As a mechanical engineer, we all understand that FMEA becomes very vital for development of a new mechanical or electrical product if you really want to ensure that the successful operation of the product is 100%. As in the case of HACCP analysis, where primary and secondary keywords were important, FMEA also have certain keywords based on which this report writing is carried out. Let us see now what are the keywords of failure mode and effect analysis. Keywords generally convey the basic and secondary functions. Basic function is about what the product does, secondary function is about what the process does. Failure mode is talking about the physical description of a failure. Failure effects talk about the consequence of failure on people, on equipment, on economy, etc. Failure cause refers to the cause of such failures. There are different variables available in an FMEA study. The most important variable which is seen in the literature is considered as severity. Severity is a rating corresponding to seriousness of an effect on a potential failure. If at all a failure occurs in a component, if that failure is going to significantly cause a consequence on the overall performance of the whole system, what would be the rating of that seriousness in a given system? So, the moment I say rating, you must understand that I am trying to quantify the consequence in terms of a number. Therefore, you need a scale. It is generally therefore expressed in a scale of 1 to 10, where 1 means the failure of this component has no effect on the overall system at all, whereas a scale of 10 out of 10 will tell me that the failure of this component is going to be most hazardous for the failure of the entire mechanical system. So, in a scale of 10, a number of 1 to 10 varying from 1 can be no effect, for example 5 can be moderate effect, 8 can indicate serious and 10 can be most hazardous. And the next important variable in an FMEA study is occurrence. Occurrence is a rating corresponding to the rate at which first level cause and resultant failure mode will occur. So, it will tell me which is the first component which is going to fail. So, where the failure is initiated is shown from this keyword or the variable called occurrence. Then it will occur in the overall design life of the system, the overall design life of the product before any additional process controls are applied. Again, the moment I say rating, I need to again express this in a scale of 1 to 10. 1 means failure is unlikely, it means it will not occur at all, whereas in case of 10 it is considered that the occurrence of failure of this particular component is for certain. So, any point varying from 1 to 10, like 1 indicates unlikely failure, 5 indicates occasional failure, 8 indicates high failure, whereas a scale of 10 on 10 indicates the failure is 100% certain. The next variable is detection. Detection is again a rating that corresponds to the likelihood that the detection methods or current controls will detect the potential failure mode before the product is released for production or process. So, detection is an observation of different mechanisms available in a given system which is capable of detecting the failure in advance or can visualize the failure when the failure is about to be initiated. Again, it is expressed in a scale of 1 to 10, where 1 means it will detect the failure, whereas 10 means almost certain not to detect the failure. So, it is a complement part of the discussion. So, 3 variables, severity, occurrence and detection, when they are multiplied together will give me a number called risk priority number expressed as RPN. RPN identifies the important areas of concern. For example, in a given system of mechanical product or an electrical product, the components are analyzed in detail, and if I am able to get an RPN of every component, the component which has got the highest RPN, that is the risk priority number, is the most critical component which should be addressed in the design, or the component should be redesigned for the overall performance of the product, which is the end development of the study. So, risk priority number identifies the important areas of concern, it evaluates severity rating, occurrence rating and detection rating of a potential failure mode. Therefore, RPN is nothing but the product of all the 3 put together. So, the maximum score of RPN can be 1000 because 10 is the scale on each one of them. Subsequently, once you know the RPN is given for a specific set of components in a given mechanical system, then what are corrective actions which are either available in a given system or were suggested by the FMEA authorities? Corrective action are to be taken if the severity is in a scale of 9 or 10, or severity rating multiplied by occurrence rating is high, or you have an highest RPN number. If any one of them is true in a given analysis, then one should take corrective actions. RPN generally is a confusing term because RPN does not have any absolute rules. What is meant by an highest RPN? RPN only gives you the relative ranking between the components in a given system. Therefore, FMEA often are viewed on relative scale. Highest RPN is addressed first. What to do prior to conduct FMEA? What to do prior to conduct FMEA? Prior to conduct FMEA, it is necessary to perform a functional analysis and then generate FMEA cause and effect diagram. Let us talk about the functional analysis. Functional analysis is done to identify the primary and secondary functions of a given product or a process. Primary functions are those specific functions which a product or a process is designed to do. For example, a mouse trap. The basic function of the mouse trap is to kill the mouse or to catch the mouse. Secondary functions are those functions that are subordinate to the primary function. For example, closing or opening the trap is one of the secondary function of a given mouse trap. If we talk about a seat belt in a given automobile vehicle, the primary function of the seat belt to hold the passenger in the seat in position. The secondary function is opening of the belt, closing of the belt, adjusting the belt tension, adjusting the belt length, etc. So, for every component you can easily identify the primary and secondary functions. Now, we do analysis on their own functions in the primary or secondary mode. What do we understand by cause and effect diagram? FMEA cause and effect diagram indicates about the failure modes, which comprises of the methods, the machinery, the material, the people, the environment, all put together can result in the failure modes. What we identify as the failure modes of a given system arising from the components. Once it is identified, then it can lead to downstream safety, then it can result in end user operation, and ultimately the design product should have a high level customer satisfaction. Now, we call these as causes and we call these as effects. So, put together is what we call as cause and effect diagram. So, after you do FMEA, you must also bridge the causes and effects in a model, what we call as cause and effect diagram. Let us try to solve an FMEA sheet for a given case study, which is an example 2, which is an airbag in a passenger car. As I said, to perform FMEA, one should first understand the working model of a given product. Let us see quickly a video how a seat belt in a given car is adjusted and how an airbag in a given system works for its safety. Let us quickly see this video. This is one of the airbag design system which is done for an automobile vehicle. When the vehicle hits, you will obviously see the person hitting the steering will have to be protected, therefore it does not cause an injury to him. If he does not, then his neck bone actually damages severely, result in damage or fatal accident. So, after understanding this particular design, let us quickly see how one can do a failure mode effect analysis of a given airbag system for a passenger car. Let us getting back to do FMEA for an airbag in a passenger car. What are the methods by which I can identify the failure? One is lack of proper warning. It arises from the understanding of the system. It can be a machinery failure, the regulator which has to invoke the airbag is not working properly. It can be a material, the airbag can be very highly abrasive material. It can be the people. If the passenger is too small, maybe a child or an underaged person, then in that case it can also cause a failure. The final one can be environment, that is the passenger is not wearing the seat belt at all, because he has to be held in position to make it safe. So these are all different failure modes in a given problem, whereas the consequences or the effects of this failure can be, it will injure the lightweight passenger, it can also cause crash to the rear seat passenger, can also result in killing of small children, because the passenger need to have a specific geometric configuration if he has to protect himself from such serious abrasion of accidents. So failures and cause. Let us talk about FMEA worksheet. This is the detailed spreadsheet of an FMEA which talks about the part or the process name, the supplier's idea and identification, the person responsible for action control, which date FMEA is performed, what is the model date, because experiments need to be conducted, what is the design responsibility, what are the areas involved which will have corrective measures, what is the engineering change recommended at different levels of analysis, what are the action results. So what is the function of the process, what are the failure modes, what are its consequences, what is the severity occurrence of these two which will give you a potential cause of the failure, what is the occurrence after you make the engineering change, what is the control you are inserting or recommending in the engineering change, what is the detection possibility of these control mechanisms, therefore what is the product of severity and occurrence now after the occurrence is revised. Originally the occurrence is different, after making the changes the occurrence is going to be further different. Now the product of severity and occurrence in detection now will give you the risk priority number, then you can always say what is the recommended action. Once the recommended action is there, after you take actions, please list what actions you have taken. After you have taken these actions, what is the severity, occurrence and detection which are changed from that of the original severity, occurrence and detection. Therefore, what is the new risk priority number. So the sheet gives me a comprehensive comparison of the risk before the design, the risk after the detection or after the recommendation, and if the actions are all completely performed, what would be the changes in the risk priority number for various components. So this is a comprehensive worksheet of an FMEA study which can be done. Now let us fill up this worksheet for the passenger car in an airbag failure. Let us quickly see one of the functions of the components, inflation of an airbag. The failure mode may be airbag is not opening. The effects could be it can injure the passenger. The injury can be very high, therefore the severity of this failure can be 8 on a 10-point scale. Of course, the occurrence of this is not detected in the beginning. The potential cause can be the sensors which should sense the opening of airbag is not working. Now you make a recommendation, correct the sensors, provide LED indicators to notify that sensors are not working. Therefore, now the occurrence is improved from nothing or 0 or 1 to 2. Therefore, you take detection because LEDs are available on the panel board to show sensors are not working, therefore it is detectable. Therefore, the severity in occurrence which will be now the product of these two, which is 16, multiplied by detection, risk priority number has become 96. Now you recommend an action saying that add additional sensors to indicate that the airbag is not opening. Once these recommendations are in place, you can again work out the severity, occurrence and detection, get a new risk priority number. Dear friends, it is very comfortable and easy and very comprehensive to prepare an FMEA for any new product which is seen working. Therefore, it gives you a very intrinsic idea about every components. So let us also take one more example, which is a mechanical wave energy converter designed, analyzed, developed and patented at IIT Madras. This is a device which is a scaled model of 1:10 of the prototype, which is designed for wave energy converter. The mechanical system has got different components: a gear rack system, a platform on which this will be mounted, a floating body, a unidirectional chain assembly, an output shaft, and an RPM multiplier. Now let us try to understand the working of this particular model before we do a FMEA for this particular study. You see, this model is a scaled model which is placed in the wave flume of oceaning department of IIT Madras. You can see that the lever is working up and forth, which initiates the rotation of the gear, which is connected to the output shaft, which converts the mechanical working of the device to an electrical energy. So the electrical energy is generated from the mechanical working of the components, therefore we call this as mechanical wave energy converter. The vital component present in this converter is a float which is made to move up and down by the wave action. This up and down motion is converted in an assembly mechanism by a gear and a rotor, which is then connected to the output shaft, where the electric generator is clubbed or coupled to the output shaft, which connects the bulb, therefore the electrical energy is generated. Having understood this, let us now try to see how an FMEA report can be prepared for working or component level failure of this particular system. These are different components available in a given mechanism which we just now saw. It is interesting to note that during the downward motion of the buoy, the wave energy absorbed by the floating buoy is transmitted to the pinion gear 6, while pinion gear 5 remains idle. On the other hand, when the buoy moves in the upward direction, 5 is invoked and 6 is released. So by the to and fro motion or up and down motion of the buoy, the gear is activated and the power is generated by a connecting shaft to the generator. So what are the components you must consider while writing an FMEA for this specific problem? The floating buoy, the pinion gears, the shafts, the anti-friction bearings, the chains, the sprockets, and of course the electric generators. What are the possible failure modes one can identify? The buoy can fail, the buoy may not move at all, the pinion gears can fail, the anti-friction ball bearings can fail, the chain drives can fail, the free wheel sprockets can fail, therefore they do not transfer power to the generator shaft, or the electric generator can fail because it does not receive enough RPM to produce power. So when you identify the different failure modes, you can easily put them in a tabular form, like the component, what are the failure modes, what are the failure consequences in an overall functioning of the converter, what would be the comment you suggest to improve the design. Now the design is improved, and now you see it is a double rack mechanical wave energy converter developed at IIT Madras and patented to IIT Madras as an engineering design done by Oceaning Department IIT Madras. Date and company are default, engineering level change are not applicable. Now different components like buoy, rack and pinion, anti-friction bearings, flywheel, one-way bearing, electrical generator. The functions are identified, the failure modes are detected, effects are shown. On a scale of 10, severity and occurrence are given, and subsequently risk priority number is slated, which gives me the most vulnerable component in a given system, which becomes the buoy. So if you do the FMEA analysis for a given component sets of a mechanical system, it is easy for all of us to understand how the failure will be sequentially initiated in a given system. Therefore, can always place the recommended actions. For example, in this case, reverse testing is recommended in the lab in a scaled model before the product is released for production. Friends, FMEA is one of the powerful, interesting, simple and basic tool to do risk analysis on working products before the product is released for commercial production. I hope you have understood the lecture and enjoyed the working models shown in the lecture, which would initiate you to do such analysis for every product development at your end. Thank you very much.